Hello everyone, welcome to the second lectures of the series Unit and Measurements. So in our previous class we learned how to find the dimensions of a given formula. So in this class we will learn how to find the dimensions of the formulas that are in the form of equations. Suppose if the equation is given like this: v is equal to u plus et. So now how we will find the dimension of this t? Suppose if it is given fx plus b by b is equal to alpha, then if the questions tell us how to find the dimension of this alpha. So when this type of questions comes, how can we derive the dimensions? So for this we have to learn some of the principles which will help us to solve this type of questions. So let us learn some of the principles and some of the rules that will help us in solving all these type of problems. So the first principle is the principles of homogeneity. The principles of homogeneity. So what does these principles tell us? These principles tell us that every terms in the equation should have the same dimensions. Suppose if we have s is equal to ut plus half of at squares. So according to these principles, this s, okay, that means this displacement s should have the same dimension as ut. Similarly, this ut should also have the same dimension as at squares. That means all the terms here, this terms, and these terms should have the same dimensions, right? Okay, we will have to, I will prove it also for you that it is true, right? So before that, let us write it down. What does this principles says? So according to these principles, every term on either side of the physical relation should have same dimension. Examples: this v is equal to u plus at. This formula we know. So that means this v should have the same dimension as u, and this at will also have the same dimension as this b and u, right? So let us prove it. So this v, dimension of v is v formula is displacement by time, right? We are finding out for this. So v is equal to displacement by time. Displacement is length and its time is t, and it should be written in the bracket. We learned in our first class. So it will be L t, when it will go up it will have the power of minus 1. Here you can write 1 as you wish. Next we have the u. So u is also one type of velocity only. So it is also formula is displacement by time. U is initial velocity, v is the final velocity. So we have the same. So it will be L1 and t will go up, means it will have the t to the power minus 1. Next we have at, a into t. So a, acceleration formula we know, velocity by time into time. So this t will get cancelled. So we will have the velocity. That means velocity will also have the same dimension as we did the upper one. So that means principles of homogeneity is correct, because here all the terms are having the same dimensions. So now using these principles, let us find the dimension of one of the physical quantity. Okay, so let us find it out. Let us find it out. Suppose we have alpha by t square equal to fv plus beta by x square. Suppose this equation is given to us. Now suppose f is the force, f is force, v is velocity, and t is time. Now question is telling us find dimensions of alpha and beta. So how you will find the dimensions of alpha and beta? Just now we learned the principles that these terms and these terms will have the same dimensions, and these terms and this term will also have the same dimensions. So let us solve it. So if you can do, you can do it, you pause it and try to do, and then check the answers with me. If you are not able to do, then look here, all of you. So how to do this one? So according to these principles, according to principles of homogeneity, this and this should have the same dimensions. So okay, alpha by t square, dimension of this is equal to dimension of f into v. So alpha t square means t is time. So for t you can directly write capital letter T is equal to force. So force means m1 L1 t to the power minus 2. This one we have done already. Now velocity, just now we did L1 t to the power minus 1. So what will be this? Alpha is equal to t will go offset, t will multiply this side. So it will be m will remain as it is. L will be 1 plus 1 2, 1 plus 1, and t to the power minus 2 minus 1. When we multiply with this, then it will be plus 2. So what we will get? We will get m1 L2 and t to the power minus 3 plus 2. So it will be minus 1. So this is the dimension of alpha. Now you have to find the dimensions of beta also. So this dimension is equal to with this dimension also. So directly you do it here. So beta by x square is equal to f v. So beta displacement means length square. It will be m1 L1 t to the power minus 2 into L1 and t to the power minus 1, right? So what will be next? Beta multiply with this on L square, so it will be m1 will remain as it is, and then L will be, so 1 minus 1 plus 1, and then when t will multiply, then it will be plus 2, and then we have t to the power minus 2 and minus 1, so it will be m1 L4 and 2 to the power minus 3. So this is how we find the dimensions, right? So alpha and beta, we got their dimensions. Next we will know the another rules. Okay, we will know another rules, and in that rules, what does that rule tell us? Let's see. So this rule tell us that rule 1. This rule tell us that if you, okay, I am writing in my own language, if you come across any equations with terms alpha plus f and beta minus x, then dimensions of alpha will be equal to dimensions of force, and dimensions of beta will be dimension of x. So what does it say is, if we come across any terms, if you come across any equations, right, when we are solving to find the dimensions, at times if you notice this term is there, whether it is in denominator, whether it is in numerators, at the time you should know that whatever is addition or subtraction is taking place, then this addition and that subtracted terms will have the same dimensions. Okay, it will have the same dimensions. In other words, you can write like this also. L plus L will give the L only, right? So this and this will have the same terms. Similarly, M minus M will give the M only. Obviously, M into M to be M square, right? And you cannot add or subtract different dimensions, right? So L plus M is not correct. You cannot do this one. You cannot add. Okay. So whenever you come across any formula where there is addition or subtraction is there, then that additions or that subtracted, okay, terms will have the same dimension. If alpha plus f is there, whether it is in dimension, whether it is in numerator or whether it is in denominator, that term will have the same dimension. Similarly, if it is subtracted, then also it will have the same dimensions, right? So let us do one examples. Okay, using these rules we will find the dimension of that one, right? So example is, we have questions v is equal to at plus bt by c plus d, where v is the velocity and t is the time. So v is the velocity, t is the time. The question is asking us find the dimension of A, B and C. Yes, we have to use the rules of both principles of homogeneity also. We have to use that rule also, and we have to use the rules that we got now. So from here what we can see, the C and plus T are added, right? C and plus T we can see here. So that means C and T will have the same dimensions. So at once we can find the dimension of C. So solution. So C will have the same dimension as T. So C, dimension of C is equal to dimension of T. That means T. This is the dimension of T. Now we will find out the AT. So this AT and V will have the same dimensions. So A T will have the same dimension as VT. But only V is there. We have the same dimension as V. So let's solve it. So A and then T. V. What is the dimension of V? Velocity. This is velocity. So velocity means L1 T to the power minus 1. So what we'll do next? This T will go down. L1. This T will go down. A. T will go down. L1 T to the power minus 1, and then T will be coming here. So what we'll get? t will go up, then to have the sign of minus, so minus minus will be added, L1 t to the power minus 2. This is the dimension of A. So dimension of A and dimension of B we got, right? Here what we did, this t will come down, okay? After that the A will be left alone, so t is coming down, and then we arrange it. Now we have to find the dimension of B. This dimension of B we have to find. So let's see how to find it, this one. So now these terms and these terms have the same dimensions, right? Or these terms and these terms are the, so we can take it anyone, whether you take this or this or this and this as you wish, because all of them have the same dimension. So we will take this B, okay? So B, dimension of B is equal to dimension of B T and then C plus T. Now C plus T means both are time, right? So T plus T, B, it will give T, and then C plus T. C what we got? It's T plus T, and then velocity is L1 T to the power minus 1. So what will be this? L1 T to the power minus 1, and then B T. What does T plus T gives? What does T plus T gives? T plus T, what does T plus T gives? T only, right? So what will be the dimension of T? What will be the dimension of B? This cancel out, so B will have the dimension of same as velocity. These questions came in JEE 2025, right? The January, right? So we are able to solve one questions that came in JEE Mains, right? Next rule we will study. Now we have one more rules. So that rules is, after learning that rule also, we will learn, or we will do some questions in which all the three rules will be used, right? So that rules tell us that so this rule is basically like, if you come across any trigonometric functions, like suppose you have sine, okay, theta, then sine theta is what? It is dimensionless. We know it, right? Dimensionless, because sine theta is equal to perpendicular by hypotenuse. So perpendicular by hypotenuse means both are length. So now both are length means both will cancel out. So that will be dimensionless. M0, L0, T0, right? So it is dimensionless. Now in the second rule, what is say? If you find any trigonometric function, any trigonometric functions, then this inside of it, whatever is there, it will be what? Dimensionless. Okay, it will be dimensionless, whatever trigonometric function is there. So this x will be dimensionless means this as a whole also it will be dimensionless, right? This sine x will also be dimensionless, whatever trigonometric function is there. Okay, whatever trigonometric functions you get, whatever is there inside of it, right? Instead of theta, whatever is there, that will be dimensionless, and as a whole also it will be dimensionless. Similarly, exponents, if you give any exponents and its power, if you find any power of it, if you find any power above it, then this x is dimensionless, right? Whatever the power is there, now I am writing the x, this x will be dimensionless, and as a whole this will also be dimensionless. Next we have log, right? And log, after that e, and then we will get some power here, okay, some value will be here, then this also x is dimensionless, whatever is there, log x whatever is there, it will be dimensionless, and as a whole also it will be dimensionless. So you just write it down, this whole, like this only you write it down. Okay, sin x is there, then as a whole x is dimensionless, then sin x is also dimensionless. Similarly, then as a whole ex is also dimensionless, and then log as a whole also it will be dimensionless. So using this rule, let us solve one questions. Okay, let's do one examples. Suppose questions is there like this. Example the one. Suppose questions is like this: P is equal to nRT by B minus B. P is equal to nRT by B minus B e to the power R e to the power a by e to the power a by R T V. E to the power a by R T V. Now, if P is pressure, V is volume, R is Planck constants, T is temperature, temperatures, and then N is mole. Okay, N is not it. It's a constant only. So now we have to, here questions may ask like this: find dimension of A and B. So we have to find the dimensions of A and B now. So how we will do this one? Question is asking us to find the dimension of A and B. I think B we can find out easily, because that one in first rule we learned after principle of homogeneity, that if addition and subtraction is taking place, then added and subtracted the term will have the same dimensions. So maybe we can find the dimensions of V, right? So what can we do here? So dimensions of V will be equal to dimension of B, right? Solution: dimension of B will be equal to dimension of B. So now B means volume, means length into breadth into height, right? So it will be length cube only. Length cube only. Or length cube means L. So this is the dimension of B. Now we have to find the dimensions of A. So how we will find this one? So now dimensions of A, how you will find? See, exponent is here, and just now we learn about that rules, that whatever is there above the power of exponent is there, then it is treated as dimensionless. So that means A by R T V is dimensionless, right? Yes, A by R T V is dimensionless. Now dimensionless means not zero. Dimensionless means whose dimension is like this: M0, L0 and T0, like this. So A by R T V. So let's take it R T V, that's it, R T V. Or dimensionless means 1 also, right? So it will be R T V only. Okay, R T V into 1, R T V. So now Planck constants, yes, this Planck constants, okay, R is the Planck constants, and the Planck constants I told you to do, right? I told you to do it in our previous class, because we had to find out the dimension of this one. Because R, P Formula, what is the formula of this one? PV is equal to RT we got, or R is equal to PV by T, right? So that means PV by T we can write PV by T into TV. So that means TT cancel out. We have PV square. Now we will bring the dimension. So pressure, force per unit area. Pressure is force per unit area, and V square is V square. So let's see. Force dimension is M1, L1, T to the power minus 2. And then we have next A. Area is length square. Now volume. Volume means length cube. Right? Volume means length cube. And again there is square is there. Right? So it will be square. So that means M1 L1 3 to the 6, 1 plus 6, and when it will go up then it will be minus 2, and then T to the power minus 2, right? 1 3 to the 6, so 1 plus 6, and then T2 when it will go up then it will be minus 2, so it will be M to the power 1 L to the power 1 plus 6, 7, 7 minus 2 is 5, and T to the power minus 2. See, we got the dimensions of the constant A. So this is how we find the dimensions. Let's do the next questions. Right, you can note it down. Okay, next we will solve it another one. Okay, example 1. Alpha is equal to F by B square sine beta. Now question is telling us, okay, here F is force, V is velocity, and T is time. So question is telling us find dimensions of alpha and beta. So you try by yourself this ones, pause it for a moment and do it. Okay, if you are not able to do, then we will do. So you pause it and do it and check your answers. So let's see how we will do this one. Right, just now we learn about the rule, this one, whatever inside of sign is there, it is dimensionless, right? So solution beta by T is equal to 1. Okay, dimensionless means 1. So now next, beta T means calculator T 1. So beta will be 1 by T. When T will go up, then it will be T inverse. So this is the dimension of beta. Next, we'll find out for alpha. Very easy. Alpha is equal to F by V square. The sine beta as a whole is dimensionless. So as a whole is dimensionless means one only. Okay. So we will leave it out. Now F. Yes, this one is the principles of homogeneity. This and this terms will have the same dimensions, right? So that's why we are writing this one. So alpha is equal to F M1 L1 T to the power minus 2. Now velocity, V is the velocity. So velocity means L T to the power 1, but square is there, right? Yes, square is there. So it will be M1 L1 T to the power minus 2. Next we have L2 and T to the power minus 2. So what will be this? What will be this? M will go up, Okay, m will remain as it is, L will go up, so L is equal to 1 minus 2 to the power minus 2. When it will go up, it will be plus 2. So that is, what will be this? So it will be m1 L to the power minus 1 and to the power 0. Yes. So we got the dimensions of both the equation. Now next questions we will do. Example 3. P is equal to alpha by beta e to the power minus alpha z k theta. Okay, e to the power p is equal to alpha by beta e to the power minus alpha z k theta. So here z is displacement, k is Boltzmann constant, theta is temperature, and P is pressure, right? P is pressures. So we know what we have to find. The questions will ask us to find the dimension of alpha and beta. So we have to find the dimensions of alpha and beta. This questions came in JEE 2023, right? So very easy. Remember that I told you that Boltzmann constant in the first lectures. The Boltzmann constants will have the same dimension as universal gas constant, that is R. So let's see. So try to solve it by yourself. Solution: P is equal to alpha by beta e to the power minus alpha z k theta is given. So here's now exponent is given. So above this is dimensionless. So we can write directly alpha z k theta is equal to 1, right? So here we can find the alpha. So alpha is equal to k theta by z will come down. So it will be like this. Alpha is equal to k theta multiply z will come down. Yes. So alpha is equal to k theta by z. So now see what is z? Z is the displacement. So it will be have the dimension of L. Theta is temperatures. So it will have the dimension of T. Now k. Yes, k is Boltzmann's constants, right? Boltzmann's constant is same as that one, universal gas constants. Universal gas constants, how do we find? P is equal to RT. This R is the gravitational constant. R is equal to PV by T, right? So we can place it here. So so it will be P B by T, right? So this TT will cancel out. So we have to find out a pressure and volume by L. So pressure means force per unit area. V. Volume means length cube by L. So next force is M1. Force will be M1 L1 T to the power minus 2, and then we have L cube. Next area is also length square, right? So next we have L. So we can arrange it now. Easily we can arrange it. Yes, M will remain as it is. L will go up. L will go up. Before that, what we have to 1 plus 3, 1 plus 1 plus 3, this 2 will go up, means it will be minus 2, and then t to the power minus 2, and then downside we have 1 L, still 1 L is there. Next, what can we write? So it's taking so long. What we write? It will be m1 and then L 4 minus 2, L to the power 2, t to the power minus 2, and when this will, L will go up, then it will be minus here 1. So that means m1 L1 t to the power minus 2, same as the dimension of force, right? So this is the dimension of alpha. This is the dimension of alpha, right? Next, can you find it out for beta? Yes. So P is equal to alpha by beta is given. This one is dimensionless. As a whole, it is dimensionless. So dimensionless means 1. So now pressure. So pressure is force per unit area. So first let us arrange it. So beta will come here and alpha by P. So alpha, what do we got now? M1 L1 t to the power minus 2, and pressure is force per unit area. Force, right? Force per unit area. Per unit area. So I think this one first is, you can write like this: M1 L1 t to the power minus 2. So this as a whole and this as a whole, it will cancel out, right? Yes, because this will cancel out and L will go up, right? Yes. Okay, let's do it nicely. Let's do it nicely, right? So alpha means M1 L1 and then t to the power minus 2 we got. Pressure means force per unit area, right? Force per unit area. So that means it will get reverse. When you will multiply, it will get reverse. So M1 L1 t to the power minus 2 into, it will get reverse, right? A will come up. A means length square, and this force will remain down. So force dimension is M1 L1 and t to the power minus 2, right? Yes. So force at this one area get reversed, okay? It get inverse when we multiply it. So now this and this have the same dimension, so we can cancel it out. So beta will have the dimension of L square. That's it, right? So this comes in JEE 2023, right? We are able to solve it. Okay, let's do one more, and after that we will go to the in our next class we will learn the importance of dimensions and its limitations. So before that we will do one questions, last questions, and practice it more. The more you practice, the more easy it will be for you during the competitive exams. Next we have, okay, this one is very easy. Okay, P minus A by B square B minus B is equal to R T. Okay, P is pressure, B is volume, T is temperature, and R is plane. Sorry, universal gas constant. So R is universal gas constants. So we have to find, questions will tell us find the dimension of A and B. So you can find it easily. The rule one that I told you about, when whenever you find any equations where there is addition and subtractions, that addition and subtracted terms will have the same dimension. So here subtraction is taking place, that means this and this will have the same dimensions. So directly you can write dimension of p is equal to dimension of a by b square. Similarly, this v and b will have the same dimension. So dimension of v is equal to dimension of b. Right? You can solve it this one. P is the pressures, a by b squares. So for today, this much only. You practice more and more. You find out the questions from DC Pandey. The books are very good. H.C. Verma, and then practice it. Okay. If you are not getting any, you are not able to solve it, then you can comment the questions that I will solve it for you. Right? So solve these answers and find out the dimensions, and then you tell me the answers. Okay, whether you are able to do it or not. So till then, study well and have a nice day. Thank you.